Hi folks, welcome back to Math with Captain Rod. I'm making this video here to provide a couple more examples here of how to complete the square. These are some examples out of your Module 14 notes. So we're going to take a look at this one first. So when you're completing the square, what you want to do is you want to get the x terms together. So the first thing, oops, get a better color here. The first thing we probably want to do is take this minus 6x, move it over to the left. The 8 we'll just leave alone. And you notice I've left some space here so that I've got a spot to add a number. Now, the question is, what number can I add here so that this thing becomes a perfect square? And to find that value, what you do is you take a look at this guy, the 6, you cut it in half, which would be 3, and square it. 3 squared being 9, so I'm going to go ahead and add a 9 there, and you have to add it to both sides to maintain equality. Now, this left-hand side, by design, is now equal to x plus 3 times x plus 3, or x plus 3, the quantity squared. And then the left-hand side is equal to 17. And I'm going to see if the directions are to solve this. Yeah. So I'm going to keep going with this. So now, what we can do here is take the square root of both sides, and on the left-hand side what we're going to have is x plus 3 equals, all right, now square root of 17, but you have to remember that this x plus 3, by the time we square it, it could be 17, but if this thing inside here was negative and squared, that would also give you 17. So the x plus 3 could equal positive root 17 or minus root 17. So we really have two solutions sitting here. And now to solve for x, we just subtract 3 from both sides. So we got minus 3 plus or minus root 17. That's about all there is to do to that. This 17 is prime. We're not going to be able to pull out any squares or anything like that. So let's take a look at the one on the right. So 3x squared minus 6x equals 5. Well, completing the square is not much fun when this is not a 1 here. So what we'll do first is we're going to take everything and divide it by 3 so that this becomes a 1. So the new line is going to be x squared minus 2x, and I'm going to leave some space, equals 5 halves. I'm sorry, 5 thirds. So what I've done here is taken this entire thing and, well, you can think of it as either divided everything by 3 or multiplied everything by 1/3, either way. And now we have a 1 here. Now we look here and we say, what do we have to add here to make this a perfect square? And to determine that, you look here. All right, that value is negative 2. The minus sign won't actually matter, but you cut that in half, which would be minus 1, and then you square it, which would be 1. So I'm going to go ahead and add a 1 to both sides. Again, it has to be both sides so that you maintain equality here. Left-hand side, by design now, is equal to x minus 1, the quantity squared. Right-hand side, let's see, is 5 thirds plus, why don't I go ahead and write that as 3 thirds, which is 8 thirds. And now we can continue on solving this by taking the square root of both sides. And again, when we take the square root of this right-hand side, we're going to have plus or minus root 8 over 3. So one possibility, I'll go ahead and write it out this time, is that x minus 1 is equal to positive root 8 over 3, or x minus 1 is equal to minus root 8 over 3. And then we would just add 1 to both sides. So here x is going to equal 1 plus root 8 over 3, and here x is going to equal 1 minus root 8 over 3. You might wonder about, does this need to be simplified? Oh, that's just a matter of opinion. I mean, I think the answer is perfectly fine the way it is. However, this 8 here, remember 8 is 4 times 2. So effectively, we can pull a square root of 4 out of that. So this one we can write as 1 plus, let's see, that's going to be 2 root 2 over 3. And this guy is going to be 1 minus 2 root 2 over 3. All right, so the completing the square part is this part when we go from here to here. That's the part that's actually called completing the square. And then from this point on, we're just solving for x. So I hope that this example, these two examples help with how to complete the square. Have a great day.